Have you ever wondered if a machine could imitate the creativity of a human artist or a designer? It's a thought-provoking question, isn't it? When we think about artificial intelligence, we often focus on automation, data processing, and decision-making algorithms. But there's another facet to this digital marvel, and it revolves around creativity. Yes, you heard it right, creativity. A domain we've long considered the exclusive realm of the human mind is now being challenged by the advances in AI. How, you ask? Well, there's a particular type of AI technology that's making waves in this area. It's called Generative Adversarial Networks, or GANs for short. These networks are designed to mimic and even enhance human creativity, producing results that can be eerily similar to what a human artist or designer might create. So, are you ready for an intriguing journey? Let's dive into the fascinating world of GANs. Imagine a master forger and an art detective. The forger tries to create perfect copies of famous paintings, and the detective tries to spot the fakes. Now, let's translate that into the world of artificial intelligence, specifically Generative Adversarial Networks, or GANs for short. In a GAN, we have two main characters, much like our forger and detective. These are the generator and the discriminator, both of which are neural networks. The generator, our clever forger, has a singular mission: to generate new data instances that look like they come from the original data set. It's like an artist in a studio trying to create a painting that can pass as a Picasso or a Monet. It doesn't have access to the original masterpieces, only copies, and it uses these to learn how to craft its own art. On the other side, we have the discriminator, our keen-eyed detective. Its job is to evaluate the authenticity of the data instances. This isn't just a passive observer, though. It's actively learning to distinguish between the real and the forged, between the original data and the generated data. Now here's where it gets interesting. The generator and the discriminator are caught in a constant game of cat and mouse. While the generator is getting better at creating convincing forgeries, the discriminator is getting better at spotting them. This creates a feedback loop, a cycle of improvement, where both networks push each other to get better. The generator wants to fool the discriminator into thinking its creations are real. The discriminator, in turn, wants to become so good at its job that it can always tell the real from the fake. It's a high-stakes game, a battle of wits and algorithms, where both sides are constantly learning, adapting, and improving. And that, in essence, is a GAN, a dynamic dance between two neural networks, each trying to outsmart the other, each pushing the other to new heights. A blend of creation and detection of forgery and authenticity. This competitive game between the generator and the discriminator is the core of GANs. So, how does this game between the generator and the discriminator work? Imagine two artists, one an original painter and the other a seasoned art critic. The painter starts off with a blank canvas, while the critic has a keen eye for distinguishing genuine masterpieces from forgeries. The painter, our generator, begins by splashing random colors onto the canvas. This randomness is akin to the noise that the generator starts with. This first painting isn't likely to fool anyone. It's far from a masterpiece. But it's a start. Now, the critic, or our discriminator, steps in. The discriminator has been studying real masterpieces and knows what authentic art looks like. When presented with the generator's painting and a real masterpiece, it's tasked with distinguishing between the two. At first, the discriminator's task is easy. The generator's work is crude and easy to spot. The critic gives feedback to the painter, pointing out the flaws and discrepancies. The generator takes this feedback, learns from it, and creates a new painting. This process repeats itself. With each iteration, the generator's paintings become more refined. The colors blend better, the forms take shape, and slowly, it starts to resemble the real masterpieces. And for the discriminator, the task becomes increasingly challenging. The distinction between real and fake becomes blurred. But the critic doesn't give up. It continues to scrutinize the paintings, looking for minute details that might give away the forgery. In turn, the generator learns from each critique, making its next painting even more convincing. This is the essence of a generative adversarial network. A constant back and forth, a ceaseless game of cat and mouse. The generator constantly strives to produce more realistic data, while the discriminator endeavors to get better at spotting the fakes. And it's through this continuous process that the magic happens. The generator, starting from random noise, becomes adept at producing realistic data, while the discriminator, with its keen eye for detail, becomes more proficient at identifying the forgeries. Through this continuous process, the generator gets better at producing realistic data, and the discriminator gets better at spotting fakes. Okay, so GANs can generate realistic data, but why is this a big deal? Well, the answer lies in their versatility and potential to revolutionize various fields. Let's start with art. GANs have been at the forefront of creating entirely new pieces of artwork. They can learn the styles of famous artists and generate new paintings that capture the essence of their work. This isn't just a fancy trick, but a demonstration of how machines can learn and replicate human creativity. Then there's music. GANs can understand the nuances of different genres and create original compositions. Imagine a future where machines contribute to the rich tapestry of our music culture, not as mere tools, but as creators in their own right. In the world of fashion, GANs are making waves too. They can analyze trends, styles, and patterns, then create new fashion designs that could potentially lead the next big trend. This could transform the way fashion houses operate by offering a whole new way to innovate and stay ahead of the curve. But it's not all about creativity. GANs also have practical applications. In medicine, for example, they can generate synthetic medical images for training purposes. This can greatly improve the training of AI models for medical diagnosis, without compromising patient privacy. Beyond these fields, GANs have a broader significance. They represent a major step forward in the field of AI. Unlike traditional models that simply analyze data, GANs can create new data. This opens up a world of possibilities for AI models to learn from an expanded, rich dataset that's not limited by our current knowledge or the data we have available. The real magic of GANs is this ability to generate, to create. They're pushing the boundaries of what we thought machines could do. They're not just tools for solving problems, but also potential sources of new ideas and insights. In a way, GANs are giving machines a touch of creativity. So, where are GANs heading? What does the future hold for this technology? The potential future applications and developments of generative adversarial networks, or GANs, are expansive and exciting. One of the most thrilling prospects is the creation of more realistic virtual realities. Imagine a world where the line between the virtual and the real becomes so blurred that it's almost indistinguishable. That's the power GANs could bring to the table. GANs could also play a pivotal role in generating training data for other artificial intelligence models. As you might know, one of the biggest challenges in AI is the availability of high-quality, diverse datasets. GANs can help overcome this hurdle by producing synthetic data that closely mirrors real-world scenarios. This could accelerate the development of AI systems, making them more efficient and effective. But as we look to the future, it's not just the technological capabilities that we need to consider. There's also the ethical side of things. As GANs become more advanced and their creations more realistic, we need to ask ourselves, what are the implications? For instance, GANs can be used to create deep fakes, hyper-realistic images or videos that can make it seem like someone did or said something they didn't. This could have serious implications for personal privacy and even global politics. Moreover, as GANs learn to generate more complex outputs, such as full-length articles or music compositions, questions about authorship and copyright can arise. Who owns the rights to a piece of art created by a machine? These are the kind of ethical dilemmas we'll need to navigate as GANs continue to evolve and permeate our lives. As we stand on the brink of the future, it's clear that GANs could open up a world of possibilities, both exciting and challenging. The key will be to harness their power responsibly, ensuring they're used to enhance human creativity and innovation, not to undermine it. As we continue to push the boundaries of AI with technologies like GANs, we step closer to a future where machines can not only think, but also create. So, there you have it, the fascinating world of GANs explained. We've delved into the realm of generative adversarial networks, unveiling their intricate mechanics and how they are shaping the landscape of artificial intelligence. In our journey, we've seen how GANs operate, with two neural networks, the generator and the discriminator, working in tandem, each learning from the other, creating an endless cycle of improvement. This dynamic duo has been at the heart of some of the most significant breakthroughs in AI, transforming the way we think about machine learning. We've also glimpsed at the future, where the potential of GANs is boundless. From creating realistic images to simulating complex systems, GANs are proving to be game changers. As we wrap up, let's not forget the significance of GANs in the grand scheme of AI. They are not just another tool in the box, but a revolution in the making. As we continue to explore the capabilities of AI, who knows what we might discover next?